Welcome back. Today I will see some alternative method of Euler equation and I will see some exercise based on this Euler equation. If you know this alternative method of this Euler equation, then you will understand any question. You can verify any question easily. First, we all of us know this Euler equation. Another alternative way of Euler equation is ddx of f minus y prime del f del y dash minus del f del x equal to 0. That imply ddx of f minus y prime equal to del f del x. And when f is free from x, that means obviously del f del x would be 0. And then this type of Euler equation would be f minus y prime del f del y prime equal to constant c. That means when f is free from x, then the Euler equation would be such type f minus y prime del f del y prime equal to constant. And when f is free from x and y both, then obviously that implies del f del x and del f del y equal to 0. And if del f del x and del y del f del y equal to 0, that implies del 2f del x to not equal to 0. Then the extremal would be y equal to ax plus b, and this is the shortcut method to find the extremal of calculus of variation easily. Okay, now I will see some example. First example, consider the set X whose content u belongs to C101 such that u0 equal to u1 equal to 0, and consider a mapping I from X to R which is defined as ju equal to integration 0 to 1 e to the power minus u prime t whole square dt, where for all u belongs to X, and let m equal to supremum of this jf and small f equal to infimum of this jf. Then which of the following statement are true? Option 1, j does not attain its infimum. Option 2, j attains its infimum at u belongs to x. Option 3, j attains its infimum at exactly 2 elements u belongs to x. Option 4, j attains its infimum at infinitely many u belongs to x. Which of the following statement is true? Here notice, here the function is e to the power minus u prime t whole square dt. That means here the function contain only u prime. That means this is independent of u. Variable is u and t, so independent of u and t, because here the function j contain f of u comma t comma u dash t, and the function does not contain u and t. So the equation would be u equal to capital AT plus B. This type of equation would be, and here the condition, initial condition u0 and u1 equal to 0. For this means u0 equal to u1 equal to 0. That means here b equal to 0 and a equal to 0. So the equation would be u which is equivalent to 0. Therefore, the extremal is this type of function and the value of the extremal is ju equal to integration 0 to 1 e to the power minus u prime t means 0 dt, and this value would be 1. And notice here the set u belongs to C101. That means this value is actually supremum value because u belongs to C101. That means this is the supremum value. So now notice the option J does not attain its infimum. Notice since this is the supremum value, that means this does not contain infimum, not contain. So option A is a right option. Option 2, J attains its infimum at u belongs to x. This is wrong. Similarly, option 3, option 4, all be wrong option. Only option A is a right option. I hope my all viewers have understood. Okay. Type of example. Notice here which of the following statement is true. Here m is supremum of this functional and small m is the infimum of this functional and same functional. That means here similar to before, this integration value would be 1 and this is the supremum value. So m means supremum, so m is attained, and since this value is the supremum value, that means I have seen few minutes ago infimum does not attain. That means option 3 is right option, option 4 is wrong option, and option 1 indicate m equal to 1 and small m equal to 0. We does not know about infimum value, so option 1 is wrong option. Option 2 m equal to 1, this is right, but here given m and small m, where small m be the infimum value, this is also greater than 0. We cannot tell about the infimum value, so this option is a wrong option. Only option 3 is a right option. I hope my all viewers have understood now. Okay. I will see one example. Here the functional is integration 0 to 1 y prime whole square plus 2y dx, and initial condition subject to y0 equal to 0 and y1 equal to 1. Then what is the value of infimum zy? Option 1 23 over 12, option 2 21 over 24, option 3 18 over 25, and option 4 does not exist. For this, the Euler equation is del f del y minus ddx of del f del y dash. Here del f del y means 2 minus ddx of del f del y dash means 2y dash. That imply 2 minus 2y double dash equal to 0. So imply 2 minus 2y double dash equal to 0, that imply 1 minus y double dash equal to 0. So that imply y double dash equal to 1, and y double dash equal to 1 imply y dash equal to cx plus d, and that imply y equal to cx square over 2 plus dx plus e. Okay. And here the initial condition y0 equal to 0, that means e equal to 0, and y1 equal to 1, that means c over 2 plus d equal to 1. Here y dash equal to x plus d. Here not c. Sorry. That means here half plus d, that means d equal to half. So equation is y equal to x square over 2 plus x over 2. This is the function extremal of this functional, and here we have to find infimum of this functional. For this, since y equal to x square over 2 plus x over 2 be the extremal of the functional, now we have to find this zy which is equal to integration 0 to 1. Y means x over 2 plus x, but here y prime whole square, that means 2x plus 1 whole square over 4 plus x square plus x dx, and this value is equal to, here this value is equal to 2x, after integrating this value would be 2x plus 1 whole cube over 3 times 4 is 12, and here also 2, that means this would be 24. Here x cube over 3 and here plus x square over 2, and here the value of the integration 1 to 0, that means after putting the value, this value would be 27 over 24 minus 1 over 24 plus 1 over 3 plus 1 over 2, and this value would be, after calculating, this value would be 23 over 12. That means option 1 is a right option. Okay. I hope my all viewers have understood this question. Okay. Next example. Let y equal to phi x be the extremizing functional for the functional y equal to integration 0 to 1 y square dy dx whole square dx. Notice here the functional is free from x, and here the initial condition y0 equal to 0, y1 equal to 1. Then what is the value of phi 1 over 4? Option 1 half, option 2 1 8, option 2 1 over 4, option 3 1 over 8, and option 4 1 over 12. For this, here the equation, since this is free from x, so obviously we all of us know when a functional is free from x, then the equation would be, Euler equation would be f minus y prime del f del y prime equal to constant. And here f means y square, y prime whole square minus y prime, and del f del y prime means y square 2y dash equal to constant. That means that imply y dash whole square, y square y dash whole square minus 2y dash whole square y square equal to constant. That imply minus y square y dash whole square equal to constant c square y dash whole square equal to constant c imply y dash equal to square root of minus c, and consider this square root of minus c, consider new constant a, and now integrating both sides, and this integration would be y square over 2 equal to ax plus b. Okay, now put the initial condition. Initial condition is y0 equal to 0, that imply b equal to 0, and y1 equal to 1, that imply, since y1 means obviously half equal to a, that means a equal to half. That means the equation would be y square equal to 2, and here a equal to half x over 2, that means the value of the equation is y square equal to x, that means y equal to square root of x. Here in the question has indicate what is the value of phi 1 over 4. Since the extremal is y equal to square root of x, then phi 1 over 4 would be here square root of 1 over 4, that means plus minus half. So option 1 is the right option. I hope my all viewers have understood this question. Okay. Next example, consider the functional integration 0 to 1 720 x square y minus y double prime whole square dx, and subject to the condition y0 equal to y prime 0 equal to y1 equal to 0 and y prime 1 equal to 6. Then which of the following be the extremal of this function? Option 1 x to the power 6 plus 2 x cube minus 3x square. Option 2 x to the power 5 minus 4x to the power 4 minus 5 x cube. Option 3 x to the power 5 plus x to the power 4 minus 2x cube. And option 4 x to the power 6 plus 4x cube minus 6x square. Notice here the functional contain not only x, y prime, here also contain y double prime. So f of x comma y prime comma y double prime equal to 720 x square y minus y double prime whole square. So for this the Euler equation would be del f del y minus d dx of del f del y prime plus d2 dx2 del f del y double prime equal to 0. And del f del y means obviously 720 x square minus d dx of del f del y prime means obviously this value is equal to 0, and d2 dx2 del f del y double prime means obviously 2y double dash equal to 0. That imply 720 x square plus 2 y4 equal to 0, and these imply y4 equal to minus 360 x square. And here after integrating 4 times, this value would be y equal to c1 plus c2x plus c3x square plus c4x cube. Here minus 360 x square. First integration would be x cube over 3. Second integration would be x to the power 4 over 12. Third integration would be x to the power 5 over 16. And fourth integration would be x to the power 6 over 360. Then this value would be x to the power 6 over 36. Just omit this part, then this value would be c1 plus c2x plus c3x square plus c4x to the x cube minus x to the power 6. Okay. And first initial condition, here for short calculation I will not use all initial condition. Only I will use some few condition. First initial condition y0 equal to y prime 0 equal to y1 equal to 0. When y0 equal to 0, that implies c1 equal to 0. And when y prime 0 equal to 0, that implies c2 equal to 0. And when y1 equal to 0, that implies, here I have one wrong. Here del f del y double prime means, notice here minus y double prime whole square. So del f del y prime double prime means obviously minus 2 y double prime. That means that imply this would be minus. So this would be plus. That means this value would be plus. So when y1 equal to 0, that imply c1 plus c2 plus c1 c2 equal to 0. Sorry, that imply c3 plus c4 plus 1 equal to 0. I will use the shortcut method. Notice here the extremal I have got of power 6. So option 2 and option 3 would be wrong. And from option 1 and option 4, since I have got here c3 plus c4 plus c1 equal to plus 1 equal to 0. Notice in option 1, here the first option x to the power 6 plus 2x cube minus 3x square. Here c3 means coefficient of x square, that means this would be minus 3. c2 means coefficient of x, and c4 means coefficient of x cube, this would be 2. And notice here the condition c3 plus c4 plus 1 equal to 0. c3 means minus 3 plus 2 plus 1. Here this value is minus 1 plus 1. Obviously this value is 0. But notice fourth option indicate x to the power 6 plus 4x cube minus 6x squared be the extremal of this function. For this, here c3 is coefficient of x squared, that means c3 equal to minus 6, and c4 is coefficient of x cube, therefore c4 equal to 4. So c3 plus c4 plus 1, so minus 6 plus 4 plus 1, and this is equal to minus 2 plus 1, this is not equal to 0. So option 4 does not satisfy this condition. Only option 1 satisfied this condition. That means option 1 is the right option. I hope my all viewers have understood this question easily. Okay? Oh well. And this is the shortcut method to find the extremal easily by chance. I hope my all viewers have understood. Okay? Oh well. Today I will stop here. In my next video, I will discuss more question of calculus of variation, because actually calculus of variation very important for higher study. Okay? See you soon. Stay safe and stay positive always, and don't forget to subscribe my channel for more videos. Thank you so much.